Alright, so in today's assignment, we're doing electricity, Ohm's Law, just like last time. And we're going to do classwork right here. And if you go today, you'll see there's a thing. It says use the PHET electrical lab to create okay, I need to fix that, circuits to last week's assignment. Take a screenshot of problems 4 and 8 and submit it here. So it says electrical current right here. That was last week's assignment. So you got to recreate these 10. I'll do number 1 with you, and then I'll maybe do number 2 as well. So first, let's go back to our Google assignment right here, and it says right here, this is the PHET lab right here. So I'm going to click that, and then I'm going to go back here to open this because I'm going to need that to recreate it. So the first one says create something with 12 volts and resistance of 12 ohms. And what is the current? Let's do that. So let's push play right here, and this should work on everything from laptops, Chromebooks to computers. It's a HTML5, so it should work pretty smooth. So if we need 12 volts, we need to click that battery and go ahead and select the battery and then move it to 12 volts right here. So make sure you're adjusting the voltage as is what is the question says. So it's 12 volts. Then resistor, we need a resistor. And you might want to put a little room here, and you'll see why in a second. Click the resistor, and it was a 12 ohm resistor. Go ahead and do that. Now electricity cannot leave the battery and go through the resistor and come back until we put a wire. So let's grab a wire, and I connect it here, and I'll drag it and connect it there. It still can't go through here, so from the negative side of the battery through and come back, it needs another wire to come completely and completely complete the path. So there we go, it's flowing. But in the question, it wants to know the current, so we got to disconnect that, and we need a little amp meter over here. Not a voltmeter, we don't need to read the volts, we need to read the amps. So let's put that there. There we go. And the answer is 1 amp. Now, you could double check your work, but if you remember, V is equal to I times R. Current, this one right here, current is equal to volts, this, divided by ohms. So 12 divided by 12 is 1. And if we go back here, you can see that the current is 1, so we are correct. So number 1 is done. And if I were to do number 2, this one wants to know the voltage. What voltage to do 120 ohms and 0.1 amps. So I'm going to make sure my resistance is 120 ohms. Let's do that first. So I'm going to make sure my resistor is 120 ohms right now. So let's go ahead and disconnect that. And let's click the resistor and make sure this is 120 ohms. And then I'm going to reconnect this. And it says to make sure that the current is how much current? 0.1 amps. Is it 0.1 amps? Let's see. It is 0.1 amps already. So we're already done. What is the voltage? The voltage is 12 volts. So if it wasn't, for example, if it said and the current is 0.5 amps, then we'd have to move this around until we got 0.5 amps. Notice this changes. I'm changing the battery, but when I give it more volts, the current changes, of course, because the more volts you put, the faster the electricity flows. So I noticed that about 60 volts right here, 60 volts gives us the current I was looking for if I was looking for 0.5 amps. However, this particular problem, it says that they want 0.1 amps, so you could just move this around until you get 0.1 amps. And that's about not 11 volts. Let's see if we can get it at 12 volts. Yeah, there we go. 12 volts will do it. So that is the answer right here. 12 volts is the answer. When I have 120 ohms and I get 0.1 amps, it requires 12 volts of current. 12 volts of voltage, I should say. And that's about it, folks. There's not much more to this. That's all you're going to need. So if you want to play around with it later on, you can. You can kind of click here. You can put a switch if you want, so you don't have to disconnect all the time. You could just put a switch and electricity flows. When you click the switch, when you let go of the switch, it shuts off. You can delete that battery. If you're just having fun later on, delete that battery and scroll around and go, oh, there's a big heavy duty battery. What does that do? Let's how much voltage is 1,000 volts? Let's go to like 100,000 volts. And what happens here? Whoa, there's a fire going on. So, and then, just play around with it and disconnect it. And explore this stuff. Look what else there is. There's a coin. See if electricity travels through the coin or the eraser or a dog. That's weird. You can connect a dog in here. That's kind of mean. Anyway, let's delete the dog. You can put your hand, you can put your hand, and see if electricity travels through your hand. Let's see here. Oh yeah, look, electricity is moving. It's actually going through the person's hand. Only because there's so much voltage here. That's probably not feeling good right there. Anyway, so that's pretty much all there is to it. So you just have to do all 10 problems. I did 2 for you already.